Okay, so let's move on to next part. So we'll start with Apache Spark. I will show few generic information about the whole idea, some use cases, our use case, and there will be some demo. I hope it will work. And then after me, Mikołaj will finish the meetup with the information about Apache NiFi. Uh, okay, so let's start with generic information. So the use cases. You know probably the Walmart company, the huge store which selling goods in United States and 27 other countries. They have 20,000 of stores, hundreds of thousands of people working for them, and they use big data tools, as Apache Spark is a big data tool, and the one situation that they have. So there was a Sandy hurricane in the United States, and they've observed that on the path of the hurricane, the strawberry Pop Tarts that healthy food is selling extremely well. So they just predicted that and checked the map where the Sandy is going and put there a lot of this stuff, except that also flashlights, emergency equipment, and so on. And it's sold extremely good. And on their scale, when they have billions of transactions daily, they would not be able to do it just, I don't know, running SQL query on MySQL database or something like that. Yeah, so that's one of the example, one of the use case. So how to use data from your transactions, the map, and earn more basically. Another one is Rolls-Royce, but it's not about cars, but the engines for airplanes they are building, and they using big data in all of the areas of their operations, and they put some hardware in their engines, which is sending data to them and help in reducing maintenance costs. So it's all automatic, all critical data they are owning all the critical data and can make decisions if, okay, you probably should not fly this plane using this engine because it will, I don't know, break or whatever, or it requires some maintenance, or they can predict. Yeah, so it's worth of changing these parts, because if we won't do it now, then it will cost us much more. And the scale is huge because the single engine contains thousands of the points that you're sending the data, and thousands of engines is flying all the time above us. The other example known probably by you is Spotify. They use also big data. They used to use Apache Hadoop. They had the second biggest cluster in the Europe of Hadoop, and they use it basically to show you what you should listen to now, maybe Rihanna or whatever, I don't know, but it's really big data. It's like dozens of thousands of servers, petabytes of data, and running all the time to just make you happier. They also use Spark in some areas, so that's related. Okay, let's move on to application in web interpret. So one example that I will show you later is we are helping eBay customers to sell their goods abroad, and items on eBay that you can go read the description and decide to buy are represented as an XML files, and we have those files, and we have quite a lot of items, and it's like 700 gigabytes of data, compressed data. Maybe it's not huge, but it's something that you probably can't process on a single laptop, and we needed to figure out some insights from those XMLs, and that was our use case. I will jump into it later. We use it also for some ETL jobs replacement. We tried with estimation engine, and maybe we'll try with warehousing. So using unstructured data, combining it using Apache Spark, and replace the classical ETL process. But that's not we'll see with that. So okay. So if you are speaking about big data, it's the probably not all, but most of the tools in big data area that were existing last year. It's not updated to this year. It's quite a lot, really, and you have multiple areas, starting with security and everything. And today we are going to speak only about this, small Apache Spark, which is actually quite great tool, I tell you. And yeah, to understand Spark, we need to go back a little bit. Maybe just a small question. Have you been using Apache Spark or Hadoop? Yes. Okay. So sorry if I will speak about something boring for you, but um, so yeah, Hadoop was probably the first big data tool, and it's owned by the Apache Software Foundation. It's basically the open source implementation of MapReduce idea prepared by Google, and it's a framework that allows you to process data in a distributed way and process a lot of data. And what is really great, you can reuse the same code, same queries, and so on, and run them on single query, a single node on your laptop, or on the cluster consisting of thousands of nodes. So it gives you a great abstraction that you can test locally, work on it locally, and then just scale and do the job. Yeah. It consists of few parts. I'm speaking about that because Spark is built on top of some of them, not all, or is sharing the same concepts. So Hadoop comes with the common part, like the common utilities that support all other modules. The really important distributed file system, Hadoop distributed file system, when you can put the data. That's not the only distributed file system you can use, but one which comes just out of the box. The Yarn framework for scheduling your work across the nodes in cluster, and the most important, the MapReduce, which is a system for parallel processing. Okay. So about the MapReduce, I will speak about that because later in demo I will show you how we do the map, and actually there is no reduce, but it will be only mapping. So mapping and reducing is functional programming primitives, and it's used in software for quite a lot. And the map operation allows you to do something on every single item or on your sequence, and it returns the sequence of the same length. So if you have a list of 10 items and you will map put it into map operation, basically each of the item on the list will be um, mapped. Sorry. And the reduce operation is basically changing the list into a single element. So you are accumulating the content of a sequence into a single value. Does it require something more? Maybe? So no. Okay. And now the Apache Spark. So it's as they write on their page, it's fast and general engine for large-scale data processing. The basic structure used in Spark is the resilient distributed dataset. It's a collection of elements that you can work on in parallel. So how you can get such structure, because you basically have to get such structure somehow to start working with Spark. So you can have existing structure, a sequence, and just parallelize it using some Spark functions, or you can reference to some existing data set which can exist on Hadoop distributed file system or AWS S3 or other file system that is accessible by your Apache Spark. And you have two types of operations you do on your resilient data distributed data set. One is the transformation, which is basically lazy. So you can do the transformation and basically nothing happens until you do some action. And those lazy operations are maps, are map or filter. And the actions take time, because when you take some actions, the job by Spark is done. And it's reducing, counting, taking some data for you from your sequence. Also, your data structures are usually partitioned. If not, it by default mean that you are processing on a single node, and it's not what you usually would like to do. And you can persist your results when you do some operation like you map and reduce. Then you can persist the results to not lose the time later, just to reuse the data you already calculated. And just shortly about the Apache Spark ecosystem. So on the bottom we have data sources, so the places from where the Spark can get the data, and it's few databases, Hadoop file system, AWS S3. This is the one we use, and you can write your Spark jobs in multiple languages. I don't know if it changed, but last time I checked, the Scala, Java, Python, and R was supported. There are also some parts that enable you to write SQL queries on your data to process data in data as a streams, but we won't speak about that. You probably can't see that. And on top, we have applications which basically you can run on top of the Spark, and which can help you in running your jobs, like Apache Zeppelin, which we'll use, and I will show you how to use it. And what is really nice, it's quite generic, and you can run the Spark on different environments, starting from your local computer to the cloud, to the bare metal servers, Kubernetes, and so on, so on. So there are multiple options where you can run your Apache Spark cluster. Okay, so when we started to solve our problem, we had to choose the stack, and we've chosen the Apache Zeppelin to create, manage, and run our jobs. And basically, it's a web-based notebook. It supports multiple interpreters, also supports Python, and we are a Python company, so it was really convenient for us. Has built-in support for Spark, built-in visualization, and so on and so on. And what was really nice for us, as we are using AWS Cloud, we decided to use AWS Tools, and the Zeppelin is already there. You can just do a few clicks and use it. Okay, so about AWS Tools. So for storing the data, we chosen the S3 object storage on AWS. We were using EC2 instances as just instances doing the work, and EMR, which is Elastic MapReduce tool from AWS, which allows you to just run pre-configured big data tools like Hadoop or Spark on EC2 instances, and you are doing it just by few clicks. It doesn't require um, much of training, and you can read um, few tutorials and start. Okay, so let's do a short demo. I will show you some simplified example, just to not go through tons of the source code. So quick reminder about our problem. So we have data on S3. Those are XML files, compressed one. There were then like 50 millions of the files and it was like 700 gigabytes of data. So we chosen the Apache Spark, chosen Python to write, Apache Zeppelin to manage our jobs, and run it on AWS. Yeah. So first, how do you run it? Basically, go to the AWS, to the EMR, and fill in that's simple form, like what do you want to do? What is the name of your cluster? Yeah, it's a cluster, or you want to execute some single step, and what software you want to run on it. Yeah, like we wanted Spark, the newest version, and with Zeppelin. Yeah, so you do that, then you choose how many instances you need or of which type, some security stuff, click create, and that's it. And in a few minutes you have you have a cluster up and running, configured, secured, and you can start working on that. So that's extremely fast way of starting. And sorry, and now I will try to show you some code. Let's hope it will work. Okay, it doesn't work. Yeah. Just a second, story. Okay, so I think it. Okay, sorry for that. Hmm. Okay, it has some delay. Sorry. Okay. So I will make it bigger a little bit. I see it bigger already. Okay. So this is how Zeppelin looks like. Basically, you have some notebooks, so that your workplaces to work. You can choose your interpreters. So in what language or how do you write your jobs? And then basically write your code. So as I told you, we've chosen Python to write, and the task was about, we have those files on S3, and we must take some data from that, which we don't have anywhere else. Like we don't have it in any database, we don't have it in any API, whatever. We just have it in those files, and those files are compressed, and we need it quickly, and it would take basically ages if you would like to write some script and download it, decompress, figure out what is inside, and then analyze. So first, you have some imports, but that's not really fancy. Then we have some definitions of functions, like function which can read the file, function that can decompress the content of the file, because the files were zip compressed. The function which takes the XPath from the file, because it's XML, and we're using XPath to extract some data from that XML. And then at the end, transform the XML into Python dictionaries. And we were interested at just few fields from the XML listed here. Okay. Oh, and sorry, because I'm not running it right now, yeah, because I'm afraid that it could fail or put some traceback, and so I ran it before the meetup. It's already finished, and I'm, won't run it again because you should never do a live demo on any meetings actually. Um, so, and the important part. So we connect to the S3. We get the bucket, we get the keys from the bucket, we parallelize them. So we have RDD here. That was the one way of creating the RDD, and then doing some mapping. Like for each key we read file, for each key we decompress it, and transform it to Python dictionary. Then we do some filtering just to throw out some fate elements of our sequence, and at the end transform the Python dictionaries into rows, some kind of data structure provided by Spark, which will enable us to run SQL queries on that data. Then some count. So count is the action, so it actually takes the time. So everything that was written before just runs almost immediately, and the count actually starts to do the work. Yeah? And it was run on some test set data, so it's only 7 files and not so much data. Yeah. Later the RDD is persisted because we wanted to reuse it later, and we create the SQL like or table like structure from our data. So now we started to have compressed files. We read the files using Spark, decompress them, extracted data that we are interested in from the XMLs, and now we are transferring it into the table, on which later basically just can run any SQL. Yeah, and that's here. So, and that's it. So we the task was quite simple, but the scale was probably too big for single instance or some scripts. And using Apache Spark, we could write such piece of code in less than a day, and then just run SQL on compressed XML files, because that's what we basically did. Okay, and that's it about the demo. Or I will show you that you can, or not. Yeah, you can do some visualization as well if you wish. So like items per country on eBay. So let's get back to the presentation. Yes, it will be on the next slide. Okay. Oh, yes. Aha. Prawo, prawo. Ja jeszcze start presenting. Chyba. Okay. Coś nie działa. Okay. So why not to build your own solution? So we take it into consideration just few elements, and what were our choices? We could build, well, after some analysis, yeah, because we excluded some other options at the beginning because they were just not good for us, and it was possible to see it without any bigger analysis. So we could build and use our own own servers and own solution when we run some background jobs, or we could learn Spark. That was our choices at the end of the analysis. So about developing, if we would decide to build it on our side, it would take some few days, and with Spark, it's up to 1 day. But with tracking those tracebacks from Spark, which are quite heavy to understand sometimes. About the cost, with our solution, we could just run it on existing infrastructure, and it would probably not increase the cost of it, but because on each servers there is still some space that is possible to use. With Spark, it costs less than $3, yeah, to do the job and to get all data that we needed, but probably more expensive than building it. About learning costs, of course, building it would be simpler because we already did stuff similar to that, let's say, but on a less scale. With Spark, we had to spend some few days to learn the really, really, really basics, yeah, because we are for sure not Spark experts, but we just know some basics. And about the query times, in Spark for those 50 millions of items, it was like minutes, like 15 minutes or something. And when we try to estimate how long it would take on our solution, if we would build it, it would take for sure hours, but probably the days. About the simplicity, both solution would be simple. You've seen the Spark code, how it looked like, and it was nothing fancy. And the last but not least, the new possibilities. We learned something new. We opened some possibilities to use Spark on other projects. We extended our knowledge, and we are very, very happy with that. So that's it from my side, actually. And now we are going to move to NiFi or have a short break. What do you prefer? NiFi. Okay. Thank you.
NiFi.